Okay, let's look at a problem here. At any point in time, 50% of drivers on the road in the United States are talking to someone else on the cell phone. Okay, now let's look at the question. What is the probability of randomly glancing around and selecting a car at random at certain points in time, also randomly selected, and having 10 drivers out of the 70 observed on a cell phone? Now, if you look closely at this question, what exactly are we doing? Well, it seems like we're counting something. As a matter of fact, what are we counting? The question says, what's the chance of having 10 drivers out of 70 observed on a cell phone? So it sounds like we're counting people talking on their cell phone. If that is the case, I think I've just defined what success is. So this smells a lot like a binomial setting. Now, I don't want you to take this for granted. We need to check really quick, and we will. Let's see. Here's my binomial setting. Do I have a fixed sample size? Yes. It's 70. Question can be asked such either an event happens, success, or it does not happen, failure. Yes, success will be someone's talking on the phone. Failure will be I don't see someone talking on the phone. Perfect. During the sampling, do I have independence? Well, again, this is a very large population. One could argue is infinitely large. Certainly, it's all adults in the United States. But I'm also interested in the behavior of adults in the United States day to day. So if, let's say, it's 130 million adults in the United States, one day there were an opportunity of 130 million, the next day another 130 million, the next day 130 million, and so on. So this is a very small sample from a very large population. Throughout the sampling, the true proportion P is fixed. In other words, is the 15% fixed? Well, unless something drastically changes, I'm going to assume it is. If during the middle of the sampling, all of a sudden there is some legislature that says that tomorrow, starting tomorrow, we're going to start finding people that are caught talking on the cell phone, then obviously that would alter that value significantly. But barring that, I'm going to assume that it is fixed. Okay, so now I realize that I have a binomial situation. Let's get down to it. I'm going to let X define the number of successes I witness, and what I want is X equal to 10. What's the probability of this happening? Now I'm ready to calculate, and if I use Excel, the command I will use is this binom dist. So I'll click on any cell, type equal to binom dist, and you'll notice the Excel gives you the things it wants. First is the number. The number that it wants is how many successes, which is 10. Trials. Trials refers to the sample size, which in this case is 70. Probability of success is going to be 0.15. And finally, false. False here means that I want equal to 10. I don't want 10 or less, just equal to 10. I hit return, and I see that my answer to 4 decimal places is going to be 0.1332. Now let's look at the same calculation using the TI-83+. So I'm going to turn my 83 on. There it is. And the command I want to use is on the catalog. So hit second key and the 0 button, which above you can see it says catalog. The command I want to use, the function, it starts with the letter B. So I'm going to click here on this button, and above it says B. You'll notice on the screen there's this little A. A means that the keys are locked into alphanumeric mode. Means that the letters are now active, not the numbers. So I'm going to click here, and immediately I'll get to the B's. What I want is binom PDF. And I'll click down here, select that, hit enter. And now what is it that I need to enter to make the probability come out here? It's similar to Excel, but in a different order. What it wants first is the sample size, which is 70, trials. comma, the probability of success, which is 0.15, comma, and lastly, what it wants is the number of successes you want to witness, 10. Enclose it, hit enter, and there you have it.